Write each of the following number as a product of its prime factors. So let's start with the number 24. We are going to do a prime factorization. We're going to use two methods here. So the first one is called the tree method. So we're going to take this composite number and we're going to factor it into two numbers that when they are multiplied gives you 24. So in this case, for example, it could be 3 times 8. And there are other possibilities, obviously. 3 is a prime number, so we cannot factor this any further. So we continue with 8. 8 can be factored into 2 and 4. 2 is a prime number. And 4 can be factored into 2 and 2. So all the circled numbers, the numbers at the tip of these branches in this tree are prime numbers. And in this context here, they will be referred to as prime factors. If we multiply these together, 2 times 2 times 2 times 3, we're going to get 24. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. A somewhat shorter way of writing this would be to write 2 cubed, because we're multiplying 2 by itself 3 times 3 equals 24. And this is our final answer. This is how we're going to be expressing it. So that was the first number. The second number they want us to do prime factorization on is the number 45. This time we're going to be using a different method. It's called the table method. So we're going to sketch out like a T-chart, a table here where we put our composite number in top right corner here. On the left, we're going to write down a prime factor of 45. So 5 is a factor of 45 and it's a prime number. So it's a prime factor of 45. 45 divided by 5 is 9. And we put the 9 down here below the 45. And then we just proceed following the same procedure. So a prime factor of 9 is 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So all the numbers on the left-hand side are our prime factors, which means that if we multiply them together, so it's going to be 3 squared times 5, that equals to 45. 3 times 3 is 9, times 5 is 45. The third number is 100. We're going to do the tree method here again. 100 can be factored into, for example, 2 and 50. 2 is a prime number. 50 can be factored into 2 and 25. 25 can be factored into 5 and 5. So the product of the prime factors here will be written as 2 squared times 5 squared equals 100. And it's always a good idea to check that this actually multiplies to 100. So 2 squared is 4 times 5 squared is 25. 4 times 25 is 100. So this is the correct answer. The next number, let's use the table method again, is 810. So this is an even number, so it means it's divisible by 2, but it is also a number that ends in a 0, which means it will be divisible by 10. Now, we cannot do this. We cannot put the factor 10 here because 10 is not a prime factor. It's not a prime number. When we're using the table method, all of the numbers on the left column have to be prime factors. So because it's an even number, we're going to divide it by 2. 810 divided by 2 is 405. 405, it ends in a 5, which means it will be divisible by 5. So we can divide it by 5. And 405 divided by 5 is 81. 81 is divisible by 3. 81 divided by 3 is 27. 27 is divisible by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay, so our prime factors here, we're going to start with the smallest one. So we have a 2 there, and we have 4 3s, so 3 to the power 4 times 5. So, and again, we want to check this. We're going to do it on the calculator this time. So we're going to do 2 times 3 to the power 4 times 5, which is 810. The next number is 192, and we're going to be using the tree method here, just alternating back and forth between the two methods. 192. Okay. It ends in a 2. It's an even number, which means it's divisible by 2. So we divide it by 2. 192 divided by 2 is 96. 2 is a prime factor. 96 will be divisible by 3. It's 32. 32 is divisible by 2. 32 divided by 2 is 16. 16 is divisible by 2. 16 divided by 2 is 8. And 8 can be divided by, I'm running out of space here, 2. And the second factor is 4. And then we're going to go to the side here. 4 is divisible by 2. So 2 times 2 is 4. So this was a larger tree. Start with the smallest factors. We have 2. And how many do we have? 1, 2, 3, 4, 5, 6. So 2 to the power of 6 times, and we have a 3 over here. And then we check. 2 to the power, 2 to the power of 6 times 3 is 192. The next number, the last number, is 720. We're going to do the table method here. Okay, so this is divisible by 2 because it's an even number. 720 divided by 2 is 360. It's divisible by 2 again. 360 divided by 2 is 180. You can factor out another 2. 180 divided by 2 is 90. Again, a 2. We could have done a 3 here as well. 90 divided by 2 is 45. And here we can factor out a 3. Not a 3, a 5, sorry, 5. 45 divided by 5 is 9. And here we can factor out a 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So our product is going to be 2 to the power of 1, 2, 3, 4 2's. So 4 times, we have 2 3's, 3 squared, times 5. We'll check it. 2 to the power of 4 times 3 to the power of 2 times 5. 720.